come on. You already know what it is. We're out here with pre-cal math, solving log problems. Nobody likes any of that. If you follow these steps, my steps, taught by Miss Wilson, you will be just fine. Just looking at this problem, what are we gonna do here? We got f of x equals log base 2 quantity x plus 5 minus 7. How are we going to convert this into that? Well, first what you want to do, before you start, you should also know that this is also known as y. I have the steps written out up here so you guys can look at that. So here we got the problem again. I changed this f of x to x. I moved the negative 7 over to the left to get x to the left to get x plus 7 equals log base 2 quantity y plus 5. Now we gotta get rid of this log. So we place a 2 in the bottom left to represent log base 2 as an exponent. This 2 and this log base 2 will cancel out. Will leave you y plus 5. What you do on the right, you do on the left. So you have to do the same steps here. Put the 2 in the bottom left, but there is no log base 2 here, so you just leave the x plus 7 up top and the 2 on the bottom. Now you have a y plus 5, 2 to the power of x plus 7. Now we gotta isolate the y by bringing the 5 over here to give you 2 to the power of x plus 7 minus 5 equals y. Sorry for the interruption. I had a little girl walk in this room and ask me a couple things, math related. So, where was I? I was here. Y, or 2x, 2 to the power of x plus 7 minus 5 equals y. This is also known as y equals 2x plus 7 minus 5. But looking at this, it just reminds you of a line. Now to find the points on the line, you have to find what x and y are. So now you plug in points for x. Down here, I made a table. I tossed in 5 points. It could be any point you would like. Just to make life easy, I tossed a negative 7 for x, because negative 7 plus 7 will give me 0. Any number to the power of 0 is 1. 1 minus 5 will give me negative 4. Adding numbers that would help lower your exponent will just make life easier. So I plugged in these points. I got in these points here. Looking at my line, I have, this is what my line came up with here. Now, you can't stop there, you have to find your isotopes too. So for this problem, your isotope will be this number right here, the leftover number on the side usually. If there's no number there, it will be 0. So also, just to help you visualize this, y, think of it as y equals negative 5. If you ignore these numbers here, just ignore that, you get y equals negative 5. So that would be your isotope. So you go y equals negative 5, 1, 2, 3, 4, 5. This line here, that is your isotope. This line will never touch isotope, but it'll get very, very close to it. Now to find your log equation, you simply flip your x tables. So what are your x's becomes the y, and what are the y's becomes the x's. You can do this because logs and exponential equations are opposites. So if they're opposites, that means x and y are opposites too. So my table is the exact same as my exponential table, just the exponents are flipped. So you do the same thing. After you do that, you'll get a purple line. Well, I call it my purple line. You'll get a line right there, and your equation will not be this one here. You want to look at your original equation with a log equation. Now, to find your isotopes, a good way to look at this is ignore everything else and just look at the x plus 5 right there. So x plus 5 equals 0. That's how you want to look at that. Now, isolate your x, hit x equals negative 5. And that is your isotope. So on your graph, you go to negative 5, 1, 2, 3, 4, 5. Purple line going through, and that is your isotope. Now you found your lines and your isotopes. Now you gotta get the axis of symmetry. The axis of symmetry will always be y equals x. So you just draw a dashed line going down the middle between the graphs, not down the middle of the chart or the plane. This here is the axis of symmetry. It's the same thing on both sides, just opposites. Thanks for watching. To find the domain and range of our exponential and logarithmic functions. First, let's find our exponential. Our exponential is the orange line right here with this orange isotope. The domain is along the x-axis running this way. Since you have an isotope flat like this as the floorboard, as a floor, our domain is not going to be bothered by this line at all, since it's going from left to right. So our domain will be negative infinity to a positive infinity. Now the range though, this will be a problem, since the line is facing like this, and our range goes from y on top to bottom, with this wall in the way. Since our graph is on above the isotope, our range would have to be from the top of the wall, which is negative 5, to infinity, going towards the top. So it goes negative infinity and 0. Now for our log problem, which is the purple, our isotope is now at x equals negative 5. Our domain goes from left to right, and with this wall in the way, we have to start at negative 5 as our point right here. Since we can't pass it, we only can go this way to the right. So it goes from negative 5 to positive infinity. Now to find our range, since this wall is going up and down, it won't affect our range at all. So you can type in or write down negative infinity to positive infinity. Now to find our x-intercepts. To find x-intercepts, you need to toss in 0 for y. As you see here, I tossed in our original equation from up here down here, and now I set it equal to 0. Now you simply solve for x. So first I brought over the 5, make it a positive 5. Now I want to get rid of the, our exponents, x plus 7. So now I created logs on both sides. Logs are the opposite of exponential functions, and this is what helps cancel it out. So I tossed in a log 2 on both sides, dividing them by log 2. Log 2 and log 2 will cancel out right here. And what you do to the left, you have to do to the right. So you have to divide log 5 by log 2. If you toss that in your calculator, you'll get 2.322. Now since we're left with our x plus 7, we bring that down. What you do to the left, you have to do to the right. So you have to divide log 5 by log 2. If you toss that in your calculator, you'll get 2.322. Now since we're left with our x plus 7, we bring that down and we simply solve for x. And you'll get x equals negative 4.678. Make sure you do not write this as your x-intercept. You must write it as negative 4.678 comma 0, because this is a point. This is not a point. This is a point. Now to find our log intercepts. Same thing. From our log problem from the original up here, we set this equal to 0 and simply solve. Once you bring the 7 over by adding it, you have to get rid of the log. First, you have to get rid of the log. And before you do that, make sure you bring everything over to the right side. Now, since the opposite of a log is exponential, and this is a log base 2, we simply toss in a number 2 on the bottom and create this an exponent. These will cancel out, but what you do on the left, you have to do on the right. So now this here is also known as 2 to the 7th. You toss that in your calculator, you get 128. Bring the x plus 5 down and simply solve for x. You get x equals 123. Toss that in as a point, 123, 0. This is the point where our log function, our orange line, or our purple line will hit the x-axis. Alright, sweet. I think that's it. Thank you for watching.